I want you to imagine a world where your mobile phone could tell if you had been drinking too much and remind you to call a cab instead of having to drive home. If you had gone through a traumatic experience, such as sexual assault, your phone would be able to tell if you were really stressed out and having a bad day and recommend that you talk to somebody. Now I want you to imagine that you are a young child on the autism spectrum. Let's say that you have a habit of shaking your hand a lot and clicking your fingers in class. This might attract some negative attention. A watch can be made for you that would be able to detect when you were doing that and send you a text message to help you learn to stop. My name is Kapide. In my 8th grade project, I researched machine learning and activity detection. I have been fascinated by machine learning ever since I first found out about it, because to me, the idea that a computer could take data and learn from it almost like a human just blew my mind. And today, machine learning is everywhere in the world around us. Whenever you use an Amazon Alexa, Siri, or Google Home, machine learning is in the voice recognition there. If you use Google Maps, it's in that to help track traffic and figure out how to get you where you want to go fastest. Self-driving cars are practically made out of it, and the Google search engine that you probably use almost every day completely relies on it. For my project, I created an app that can detect sitting, standing, walking, and running. Now on its own, this app is pretty cool, but it doesn't have any purpose. All it can do is detect what you're doing. So I did a little bit of research, and I found out about this thing called the 20-20-20 rule. This rule states that every 20 minutes, if you're reading a book or looking at a computer, you should stand up and look at something 20 feet away for 20 seconds. Doing this helps keep your eyes healthy. So I added more code to my app. So instead of just detecting what you can do, it can get that information and then use it to help you. I started by collecting data from 10 of my friends and family. I had each person I was collecting data from do each of my 4 activities, sitting, standing, walking, and running, for 20 minutes. 20 minutes total, 5 minutes for each activity. I had to collect data from 10 different people, because if I only collected data for myself, my app would only learn how to detect my sitting, or my standing, or my walking, or my running. When I collect data from lots of different people, it can generalize and say, well, standing is when the phone is vertical and the person isn't moving, not how do I stand specifically. So it's better at detecting, it's more usable for other people. After I had all my data, I brought it onto my computer and I cleaned it up and just removed the parts that I didn't want, like if somebody had dropped the phone, because that would mess up the program. After that, it was time for me to pick my features. A feature is a way of taking a lot of data and condensing it into a single number that is easy for a computer to understand. There are lots of different mathematical functions that you can use to calculate a feature, but the ones that I chose were mean, standard deviation, energy, and correlation. So for an example for mean, if I wanted to see how much the person was moving forward in the last 4 seconds, I would take the mean of the x-axis acceleration in the last 4 seconds to see how much they were moving forward. Or if I wanted to see how much they were bouncing up and down, I would look at the standard deviation of the z-axis. Standard deviation is just how much does the number vary. So it can tell me how much it's moving up and down. After I had picked all my features and calculated my data with those features, I was ready for machine learning. Machine learning is when a computer gets data that is split up into different groups and it learns to distinguish between them. So in my case, I would have a group for sitting, a group for standing, and a group for walking, and a group for running. And the group for sitting would have all of the data that I collected for the people who are sitting in that one group. And the computer looks at that group and tries to find a pattern in it. So for sitting, it might find a pattern that the person isn't moving and the phone is horizontal. But the goal is to distinguish between groups. So then the computer would have to look at standing and see, okay, the person still isn't moving and the phone is horizontal. So now it can tell sitting and standing apart, because in most cases the phone isn't moving, but it can tell whether it's vertical or horizontal. So then it would do the same thing for running and walking. In that case, it might see that, okay, it's bouncing up and down or something. So there are lots of different algorithms that you can use to teach a computer the differences between these groups. The one that I found to be the most accurate is called a random forest classifier. Now, a random forest classifier is made up of decision trees, and the decision tree, which I have an example up here, is exactly what it sounds like. It's a tree of decisions that the computer can make to try and figure out what you are doing. So again, back to my case, the first thing the computer might ask is the phone bouncing up and down? And it can tell that the phone is bouncing up and down by using standard deviation. So then let's say, yes, the phone is bouncing up and down. Now the computer is going to ask, well, is the person moving forward quickly or slowly? And if the person moves forward quickly, then they're running. And if the person moves forward slowly, then they're walking. But if the phone wasn't bouncing up and down, well, now it knows it can't be knows it can't be walking or running. It has to be sitting or standing. So it's going to see, well, is the phone vertical or horizontal? And I can calculate all of these using the features that I talked about before. So in my research, I trained 418,230 different models. And that sounds like a lot. It is. It actually took 3 days to test all of those. And what a model is, when I have all my data, I give it to the computer and ask it to learn from it. And the computer learns from it and tells me, well, this model got most of them right, or none of them right, or all of them right. So for each of those models, I know how accurate it is, and then I can look at the most accurate ones. So the most accurate ones actually use the random forest classifier algorithm, which I talked about before. And my most accurate model had an accuracy of 95.96%. That's actually pretty good in machine learning. So once I had the model ready, I needed to put it on my Android phone. But all my previous programming had been in the programming language called Python. And Android phones talk in the programming language called Java. So I used a library for Python that I could use to convert from Python to Java. Then I created an app around this, so my phone could detect what I was doing. But again, this doesn't have any purpose. It's cool, but it's not very useful. So I added a little bit of extra code that can keep track of how long I've been sitting for. And if I've been sitting for more than 20 minutes, it sends me a notification reminding me to stand up and look at something further away. So I have the app running on my phone right now, and I'm going to demonstrate it. Grab a chair. The phone runs on any Android phone, and it's supposed to go into your right pocket, because that's how I trained it. If I sit down, I should switch from walking to sitting in a little bit. Yeah. So I'm walking, and it can detect running. I'm not going to run here. And I also trained it for standing, but it has a lot of trouble detecting standing from sitting. So you can see right now it thinks I'm sitting. I have to stand in a very particular way for it to detect that. I'm still working on why that is and trying to fix it. Yeah. So when you go home and use Google Maps or search Google for a good dinner recipe, I want you to think about all of the machine learning, all of the math, all of the feature calculation, all of the training, and all of the data collection that went into just giving you that one example. Thank you, and are there any questions? I give it data and it can learn from that. And the only data that I gave it was data of the phone in my pocket. So if I put the phone in a purse, it would be swinging around so much, it would probably think that I was walking, because it never learned what being in a purse is like. But if you notice, if I put it on a table, it thinks it's sitting, because it doesn't know the difference between being on a table and being in my pocket. And Elena.
How long did it take you to create the app in its entirety?
So I started my project in September. By around November, I had collected all the data from all of my people. By January, I had ran my 418,230 different models and picked the best one. And then I didn't actually finish making my app and get it fully working with the 20-20-20 rule until just a few days ago. So I've been working non-stop on this project since the beginning.
Do you have any plans on what you want to do with this in the future?
So, as I was talking about before, activity detection on its own isn't really useful. You need to give it a purpose. So, in my case, I had to follow the 20-20-20 rule, but it can be used to help detect depression. It can be used to see if somebody's drinking too much. It can be used to help detect stress. Activity detection is really useful for a wide variety of things. So I think I'll probably try and find another use for this and get a lot more data so it can actually tell standing from sitting. Okay, Carl.
I know this is good, but if you were gliding, what would it say?
If I was gliding?
Not ready. What would it say?
I don't know. I mean, we could test that. I think it just thinks I'm walking because I'm moving forward at a slow speed. That's probably what's used to me when I'm walking.
Now it thinks you're sitting.
Yeah, I thought, yeah. Jack.
So is it true that while working on this project, at no point did you ever follow the 2020 plan?
Yeah, that is very true. I tend not to do that.
That's why he needs it. Yeah, exactly.
So actually, I will say, once the app was finished, I noticed that I was beginning to use it. So it is useful. Like I was writing an essay or something and I used it, yeah. Okay, yeah.
I'm just wondering what exactly inspired you to do this, and also how did you know all these different things to do it?
So
Where did you learn about
I found out about machine learning a few years ago, and as I said before, it just blew my mind that a computer could do this. And one of my parents' students, his name is Nicola, he was my mentor for this. So I've met with him basically every Wednesday since September. And each time, he'll explain to me a little bit of what I need to do, but he also expects me to go and do my own research. So a lot of this stuff is information that I found on my own, and I did. So he'll tell me what I need to do, but not how to do it. So I'm in charge of going and doing research and looking at what I have to do. I research other people and how they've done this exact same thing. Yes?
So, can this information then be sent to anyone's computer? In other words, say you had someone in your family who had Alzheimer's or something like that, or was living independently at home, could it be sent to a family member's computer that you would know, oh, they're out of bed now, they're getting up and walking, so could you...
Yeah, so right now, all that happens is that it's on my phone, and I'm sharing my phone screen with my computer, but I could change the app so that I could send it to anyone. I could send you an email each time I made a detection. I could create another app for a laptop or a PC that just syncs with this. And so it could be something like that. Now, if I wanted to use it on somebody who had Alzheimer's, I assume that their walking would be slightly different, so I would need to train it on them. But the basic idea would still work very well.
You'd have to train it on each individual to make it work.
Yeah, if they all walk differently. The nice thing about training on these people is that we all generally walk the same. Nobody's like, it usually works.
Two more questions.
That's right.
So, what if somebody's lying down? Does it just think they're standing?
If somebody's lying down. No, because if somebody's lying down, the phone ends up just being horizontal.
Okay.
So it's going to detect sitting. Well, it's sitting. Yeah. Okay. Yeah, Sebastian.
So could you have it so it could detect how long you've been sitting in one day and how long you've been standing? And then it could tell you that was something I could do. Did it really help for
Yeah,
the way you've been doing that?
I could do that. And right now, actually, what I'm doing is I have it tracking sitting, but only for the last 20 minutes. I could extend that so it tracks sitting for the whole day.
Right.